Hello everyone, this is Evgeny again. In the previous video we discussed what the architecture of our system should look like. Today we are continuing our video series on building a custom trading software in Python, and today we will implement the first working prototype. We will load data from MT5, calculate a simple moving average, visualize the chart and review the structure of the project. Most importantly, you will see how the structure is organized, so that in the future it will be easy to add new indicators, strategies and interfaces. This is a crucial step because it shows how models interact with each other and provides a platform for future improvements. I wrote the code itself fairly quickly. Most of the time went into preparing everything for the video. I didn't want to overload it with unnecessary details or, on the contrary, miss anything important. Turns out it's not that easy to present the information in a simple and clear way. In the previous video I originally planned to show a complete moving average strategy, but while implementing the code within the planned structure I decided to take a smaller step and try to release videos more frequently. This is because giving too much information at once makes it harder to structure clearly. Let's begin with what we currently have in the project. First of all, main.py, the entry point. Visualize sma.py is a visualization model. In this case, it plots a simple moving average and closing prices. Although perhaps this isn't quite correct, since our goal was to create a universal structure, not a visualizer for a single indicator. But I'll fix that later. Core.py is the core model. Builder.py is our strategy aggregator. It collects all defined branches indicators and builds a complete strategy out of them. Signals.py, well, this model is used when generating trading signals. Right now it simply forwards the call since we are not yet focusing on live trading. It also acts as a link in the data pipelines used for visualization. For now, we just created the skeleton where we'll add more indicators in the future. We have displayed one indicator and closing prices on the chart. sma.py is our model for calculating the simple moving average. And the last model is loader.py. It's needed to load the data. As I said earlier, at the initial stage we are importing a CSV file with historical price data. That's what this file is responsible for. Later it will also support working with 0MQ, though I may create a separate model for that. And to avoid conflict, I will make sure the file is loaded only from one selected source at a time. So what do we have right now? Essentially, this is just clean code. There is no user interface yet. If you want to change any parameters, do that in the code itself. I launch everything through the command line. We'll start with a basic description of the model's functionality, then look at the prepared block diagram. We will go through it step by step to see what gets called and in what order. After that, we will run main.py from the command line and see the result. I'll also say a few words about exporting the CSV file from MT5. You may disagree with me, but I find it inconvenient to start the overview with the main file. If we start there, we end up requesting data we don't know anything about yet. So I'll begin with the branch responsible for loading the data, the CSV file. Loader.py, a data loader. This model provides a universal interface for accessing historical price data, prepared for further processing. What it does in general: reads data from a CSV file in UTF-8 encoding, ensures the file contains a date column, converts values in the date column to datetime type, sets date as the data frame index. This makes it easier to work with time series, plot charts, and align data by time. Returns a ready-to-use data frame suitable for analysis and signal generation. There is nothing particularly difficult in the code itself, just a few nuances in how the input file is formatted. The data format must be like this: year, month, date. Columns are separated by tabs. I noted that in the code. Column name must also be present. Since parsing is done by date and the date column must be defined, it would probably make sense to handle multiple formats and convert them to the one we use, but I haven't done that yet. What I mean is, in the source file, instead of tabs, it could use semicolons, the date might use dots instead of dashes, and so on. Let me briefly show how I export data from MT5. To export it, you need to compile the code you are looking at now in MetaTrader. There are a few key points. We specify the name of the CSV file. We choose the correct time frame and number of bars to export. It might be more convenient to specify a data range instead, something to keep in mind for later. Then we define all the columns that will be included in the file. We set the date format, we already talked about this earlier, and finally an important part, digits. This automatically defines the number of decimal places based on the currency pair. For example, for euro-dollar, it's 5 digits. If you mistakenly set it manually to 4 digits, the result will be complete nonsense. I once spent half a day trying to find an error just because I manually set it to 4 digits, so don't make the same mistake I did. Now sma.py. This module performs the mathematical calculation of the simple moving average when called. What does it do? It receives a time series, in our case the closing price, takes the period and shift, for example shift by 1 bar, or validates the input parameters, calculates the moving average and applies the shift, returns the resulting indicator as a PD series. The calculation itself is literally one line of code. The rest is minimal validation, like ensuring the period and shift are above certain values. This model knows nothing about visualization, buy-sell signals, or any other logic. It only does the calculation. Other models call this one through the core when needed. In this structure, it's easy to add more indicators. You simply create a new file, name it for example RSI.py, implement the calculation logic inside it, and pass it to the interrogator. At this stage, we are only using two models, loader.py and sma.py. Now let's move on to signals.py. This code implements a strategy based on a simple moving average. It generates signals based on the input. In our case, the closing price. It uses relative import, which means sma.py should be located in the indicators folder. What does this code do? It creates an instance of SMA indicator, which is used to calculate SMA. It stores the period and shift parameters for later use. It caches value to avoid recalculating for the same data. The generate method is the main one. It receives a time series. If the data is the same as in the previous call, it returns the cached SMA, otherwise it recalculates using SMA indicator calculate, stores the result and returns a new series. GetSMA is a helper method that retrieves the SMA without rerunning the full strategy logic. It's used by the visualizer. The internal method is same series, checks if the current series matches the one used for the last SMA. It checks the index and length. This is used to decide whether the cache can be used. Overall, this model defines the behavioral logic of the program, how signals are formed. Next up, builder.py. What is this rule-based aggregator class? It's an aggregator for rule-based strategies. It wraps a specific strategy, SMA strategy signal from signals.py, and gives access to its functions through a signal interface. Its main job is to accept data, apply the strategy, and return the result. In a sense, a rule-based aggregator is a wrapper. It doesn't know how the strategy works internally, it just knows how to interact with it. It delegates the computation to SMA strategy signal. You can think of a rule-based aggregator as a manager. The manager doesn't write the code, but knows how to call. It receives the tasks, passes it on, and returns the result. SMA strategy signal is the executor. It knows how to calculate the SMA and generate signals. So builder.py acts as a single entry point into the strategy. It connects the core to the strategy logic. It's easy to test, and you can replace the strategy or parameters without changing the code. I want to highlight this line. It pulls the period and shift parameters from the config, with default values of 10 and 0. Keep that in mind. It also creates an instance of SMA strategy signal, linking the core logic with strategy logic. This model has two methods. First one, run, the main method for generating signals. It receives a time series, passes it to the strategy generates method, and returns the result. GetSMA, a helper method that calls getSMA on the strategy. It retrieves the calculated SMA and is used by the visualizer. This file implements the aggregator pattern. It's responsible for creating and running the strategy. It makes the system flexible and expandable. You can add new strategies, and the core won't care about how they work. All parameters come from the config. Next model, visualize sma.py. This is a visualization model. It receives data from the engine, plots price and the indicator like SMA. It can be replaced or extended for other indicators. Its job is to get the config from engine config, retrieve the price series, get the calculated SMA, ship the indicator forward in time, plot the price and SMA, show the result to the user. Basically, it's a presentation layer. It uses data from core engine but doesn't affect logic. You can replace it with another visualizer, like Plotly, Dash, and so on. In the future, you could add support for multiple indicators, crossover points, saving charts, interactive element, or using other columns besides close. It's up to your logic. Next, core.py. Now we are getting to the heart of the system. Core engine is a central orchestrator. It handles configs, loads data using data loader, runs the strategy via a rule-based aggregator, and provides access to prices and indicators. Its main job is to load, execute, return result. The class handles initialization, data flow, providing access to other parts of the system. What it does in practice: stores the config and creates the aggregator, loads CSV data via data loader, runs the strategy on the data, returns the price series and SMA via methods. It's the hub of the system. It doesn't know how the strategy or indicator work, but it knows how to interact with them. There are four main methods. The first one is load data. It loads CSV data via data loader from CSV, checks paths in config, saves the result in self data. The second, execute. Run the strategy based on the price column, gets the column name from config, checks for it in data, passes it to aggregator run, returns the result. And third and fourth, get price series and get SMA. Both of them helper methods used by the visualizer. And finally, main.py. This is the entry point of the trading system. Its job is to load config, create the core engine and start the process. In short, import the core and the visualization model, defines config, CSV path, indicator and strategy parameters. Creates the core instance, loads data via data loader, executes the strategy, prints the last signals, displays the chart. Main.py is a high-level model that ties everything together: config, core, strategy, and visualization. Later you can extend it, add dynamic path detection, save result, support multiple strategies, login, error handling, and so on. Earlier, I asked you to remember that builder.py sets default values. In main.py, we set period and shift again, but these values take priority over builder.py. It's a fallback. If main.py doesn't provide them, builder.py defaults are used. Now let's go through the steps one by one. Step 1. Run main.py. Import classes and functions. Define config. Step 2. Initialize core engine. Save config, create rule-based aggregator. Step 3. Initialize a rule-based aggregator. Save SMA parameters, create strategy. Step 4. Initialize SMA strategy signal. Store period, shift, create SMA calculator, set up cache. Step 5. Load data via engine load data. Step 6. Read CSV via data loader. Check for date column, convert dates, set index. Step 7. Run strategy via engine execute. Get column, run aggregator. Step 8. Generate SMA. Check if data matches, use cache or recalculate. Step 9. Print signal. Plus 5 SMA values. Step 10. Visualize chart. Get data, shift SMA, plot and display. Step 11. Program ends. Data processed, chart built. We have now taken our first practical step toward building our own trading software. Time to run MT5 and see the result, and compare it to the same chart in MT5. Here's our chart, and here's the MT5 version, with the same currency pair. They matched exactly, though MT5 has a few more recent dates. I've marked the earlier range in red, that's the part our software doesn't cover. So the first step is complete. Now we can expand and improve our system. If you found this interesting and want to see more of this development process, subscribe, leave a comment, ask questions, like the video and hit the bell. See you in the next one.